Can you see my
Yeah.
screen and hear my voice?
Yes, everything is fine. You may start.
Okay, so good afternoon, Professor and colleagues. I'm Ponwit Kapgat, and my advisor is Professor Elena Kuyasina. And my thesis is the bioenergy supply chain simulation and improvement based on Thailand Alternative Energy Development Plan. So in this presentation, I have totally 8 topics. So let's start with the first one, the background and problem statement. Okay, so in Thailand, we have our our own energy development plan, which is called Thailand Integrated Energy Blueprint, and this blueprint categorized into 5 different subplans, which is describe the different energy issues. But I want us to focus on this one, the AEDP, Alternative Energy Development Plan. And in this plan, the AEDP determine the alternative energy consumption in each year, in the future year. And for this year, in 2021, it also have the target consumption as I shown on this table, on this column, the target consumption. But if we see the real consumption here, we can see that Thailand reached the goal, uh, hasn't reached the goal yet. Uh, not yet, sorry. Hasn't reached the goal. We can see the difference from the real consumption to target as in the last column here. And with this reason, so I decide to investigate what problem why Thailand hasn't reached the goal in these alternative energies. So my thesis goals, the first one is to make the mathematical model and simulate Thailand's bioenergy supply chain. But in my case, in this thesis, I will focus only in biomass, biogas from energy crops, and bioethanol only. The second goal is to investigate the problem that make the real bioenergy consumption of Thailand less than the target we plan. And the last one is to make some suggestion to improve the Thailand bioenergy supply chain and help Thailand accomplish the goals we plan according to the AEDP. Okay, and here is some literature reviews. In this paper, they did an overview of the bioenergy supply chain optimization and present about what issues we have to consider when we do about the bioenergy supply chain optimization. So the first issue is the logistic process. We have to consider about the biomass harvesting. Is there any some pre-processing process before the production process? Also about the storaging, transportation, and energy production. The second issue is the objective function of the optimization. So we want to minimize the cost or maximize the profit. And what the methodology we use, we can do mathematical programming or use some software to do simulation and optimization instead of conventional mathematical programming. And here is another paper, which is the study about the bioenergy supply chain optimization in Thailand. Here, their objective function is to minimize the total cost in the supply chain, which consists of the harvesting and transportation cost, holding cost, which is the same as the inventory cost. It is the same one, and the fixed cost of the power plant. The constraint, the inventory constraint, the biomass usage constraint, plant selection constraint, demand constraint, and supply constraint. And here in my case, so here is my bioenergy supply chain in Thailand for my case. In the supply chain, we have totally 4 players. The first one is suppliers who produce different type and different amount of biomass. The second player is the transporter who transport biomass from supplier to power plant. The third player is the power plants or factory or energy production factories who produce energies. And the fourth player is the consumer who consume energy. And here, in my case, I consider totally 17 types of biomass. And for biomass power plant in Thailand, we use three different technologies to produce electricity. First one is cogeneration. Second one is direct firing, or another name is direct combustion. And the third one is gasification. And biogas power plant in Thailand, we use just an anaerobic process, anaerobic digestion to produce biogas before feed into the boiler to produce electricity. And for ethanol plants, we use fermentation process. And I have to mention that different technologies come up with a different energy efficiency, which I will talk about the energy efficiency in the further slide. And here is the detail. We have in Thailand, we have 77 provinces which supply different types and different amount of biomass. We have 17 biomass types, 215 biomass factories, biomass power plant, 185 biogas power plant, and 27 bioethanol plants. And here is the methodology I use. Okay, first one, speaking about the data collection. I collect the data from mostly from the website of Ministry of Energy of Thailand. We have 77 provinces. We have totally 727 plants. And here is the energy efficiency with different technologies. And in Thailand, we use two different transportation modes. For non-biomass, non-molasses biomass, we use the 10-wheel truck. But for molasses biomass, we use the petroleum tanker truck. And for the mathematical models, I use Python version 3 to do the linear programming. I have 4 groups of variables. The first one is the amount of biomass delivered from suppliers to power plants at each time period. The second group is the amount of biomass fed into the energy production process. First one is inventory level, and the last one is the maximum inventory level. So totally, I have almost 7.5 million variables. And for parameters, we have to know the biomass available from each supplier at each time step. The distance between suppliers and power plants, the plant's profile, such as energy efficiency, maximum capacity, and cost, and etc. And the last one is the energy demand. Okay, my objective function is to minimize the total cost, which consists of the biomass cost, transportation cost, annual production cost of power plants, and the holding cost, which is the inventory cost. It is the same meaning. And the constraint I consider, the first one is the biomass available limitation at each supplier. The inventory change at each time period, and also the inventory limitation at each power plant. The biomass fed into the energy production process at each time period, which cannot exceed the inventory level at that time. The power plant's maximum production capacity, the maximum production limitation. And the final one is the energy produced from power plants have to equal to the demand. Yes, and here is my current progress. So what I know now that with the current supply chain profile in Thailand, with the current amount of biomass and the current power plants production capacity, they cannot satisfy the target consumption as we plan according to AEDP yet. So the question is, how much bioenergy potential does Thailand have in the present? So to find this answer, I change the objective function to maximize the total energy output and change the demand of electricity from biomass electricity demand from biogas and the bioethanol demand to variables, and then optimize to find these three values. The constant are still the same as I present in 5.2, which is here. The constant is still the same. And the result I got that the biomass, electricity from biomass demand is as 3,940 megawatt, which is the target demand, which is, so that means the biomass can satisfy the target demand. For bioethanol demand is at 4.79 million liters per day, which is also satisfy the target demand. But for electricity from biogas, it's just about 86 megawatt, which is still which does not satisfy the target yet. So then to see if we produce energy as maximum bioenergy potential, how our supply chain will be. So I substitute this value to the old model, which is the objective function is to minimize the total cost. Okay, I substitute this number to the demand. Okay, and okay, the constraint are same, and the result I've known now is okay. All biomass type are used to generate the maximum possible energy, but not all power plants operated. What does it mean? It means that okay, the current biomass we have right now is less than how to say it? It's it means that we need more biomass to satisfy the target. But for the power plants, which I haven't put the data here because I have 427 plants, so I avoid to attach it in the slide. But it seems that we have enough power plant capacity to satisfy the target, but not enough biomass right now. So that means we have to improve the supply chain. And here is my future plans. So the first one, I have to analyze the supply chain right now. What is the bottleneck occur? And then since not all power plant operated, so which is not so realistic because they already build the power plant. So that means they should produce energy and sell energy. So I have to improve the model by making some condition or constraint to have all power plant operate. And the first one is, okay, we know that we don't have enough biomass, but maybe enough power plants. So the question is, okay, we have to grow more biomass, but how much and where? Or in case that which the current power plant couldn't satisfy the target as well. That means we also have to build a new facility. But since I have to analyze my current result first because I still in the progress. But in case that we have to build more power plant, the question is how many power plant, how much capacity, and where to build it to satisfy the target. And here is my plan schedule. In the end of this month, I have to finish my improved models. And then next month, I have to analyze our data, compare our data in different cases, and then finalize my report. So, okay, in conclusion, my problem is Thailand actual bioenergy consumption are less than the target. And my goal is to make a mathematical models and simulate the Thailand bioenergy supply chain, analyze the bottleneck or the problem in the current model, in the current supply chain, and then make some suggestion to improve the supply chain to accomplish the goal. And I use Python to do linear programming. My current progress right now, that current progress is we know that with the current condition, it cannot satisfy the target. And we have to build, we have to grow more biomass, or maybe have to build more power plant as well. My future plan is, first one is to analyze, the current bottlenecks in the supply chain, and then improve the model, and then summarize all case, compare them, and finalize the report. And this is all my presentation. Thank you.
Thank you, Paul, for the presentation. Any questions to the student? Any? Probably you have one.
Well, I had discussed many aspects already with Paul before, and
Okay.
so, I mean, I can only comment and say that he's made loads of progress, and so I encourage him really to finalize this work. But the point is also maybe for the growth of biomass, there may be innovative solutions for to stimulate this.
So, excuse me, what do you mean, please?
Because the point is, you see, because you need to have more biomass, yes, to generate all this, yes.
Yes, yes.
Because part of the biomass goes for food consumption, yes?
Here we consider just the agricultural, the leftover from agricultural harvesting.
Yes, but the leftovers, you have more leftovers when you have more volume, in fact.
Sorry, you mean after
so you would get more fuel from leftovers if you have more leftovers, perhaps also. So yes. There would be some incentive to but okay, it was just a small remark. But okay, thank you.
Okay, thank you so much.